Welcome to the AP Chem 2022 FRQ video series. Today we'll be solving question 5 of the 2022 AP Chem pre-response questions released by the College Board. Whenever a question pops up on the screen, please pause the video and read it to yourself. So number 5 is a rate law problem. Part A asks for the value of the rate constant of this reaction. We're also given the rate law and we are given a table of the concentration of N2O5, the reactant, with the time. So we also need to be including the units as well. When we look at the table, we can observe either here or we can observe over here. Observe that the concentration is decreasing by a half, which alerts to me that we can be using half-life, and the half-life formula is 0.693 over K, which is given on your formula sheet. And if you find the time based on the values in the table, then you can isolate K and get your answer. So let's find the time. It's going to be, so I'm just going to use this over here. So that'll be 3.33 hours minus 1.67 hours, and that is 1.66 hours, and this is going to be the half-life, so 1.66 hours and then 0.693 over K. That, when we punch in our calculator, is going to be 0.415 hours to the negative first power. And it's definitely important to just like have your units throughout so you can get your units, because I'm pretty sure that there's going to be a point just for the units. In part B, we have a reaction mechanism, and we're asked which step is the rate determining step, and they're also alerting our attention to the rate law given, which was up here. So now what we have to do is get this rate law and see which one of these steps has a rate law that matches the given one. So when we do that, I can see that step one is the rate determining step. Because its rate law of matches the rate law given. Okay, that was an easy one. You don't want to, overthink it. You just want to see which one has a matching rate law. I see step 1 has a matching rate law. I don't even need to look at the other two steps and worry about anything else, and I can save time. So now part C asks that if this experiment was repeated at the same temperature, but then they doubled the initial concentration of the reactant, what would happen to the value of K? This one also might be very easy to overthink, but you have to remember that K would stay the same. And this is because changes in concentration do not affect the rate constant. So this was a conceptual question. This does not affect the rate constant. And if you want to be really extra here, you can say only a temperature change or adding a catalyst would change K. And since temperature is constant, that's not happening. So there you go. That's all for this video. Thank you for watching and good luck studying.